Hello everyone, welcome to the part 2 of module 5 cables and suspension bridges. So in this module, let's see the cable subjected to uniformly distributed loads when the ends are in same level. That means the analysis of cables which is subjected to a UDL of intensity W per meter and whose ends are in same level. So let a cable of length L be supported at the points A and B which are at a horizontal distance L meter apart and are at same level. Okay, here you can see the supports A and B are in the same level. So let the cable be subjected to a UDL of intensity W per unit horizontal length as shown in figure. Okay. Now let C be the central part of the cable and H be the central dip of the cable, and theta is the angle made by the maximum tension with horizontal. So this is the tension in the cable and theta is the angle made by the tension with the horizontal or with the thrust. Okay. So this is a typical cable subjected to UDL, and here you can see the free body diagram of cable. Here you can see the central part is see this, and this is a tension in the cable, and this is a support A, and which is acted upon by the reaction VA, and the horizontal thrust H is acting outwards, and which is subjected to a UDL of intensity W per meter, and consider it is acting for a length H. Okay, now because of the symmetry we can equate, that is, or we can find VA equal to VB equal to W into L by 2 since the load is a UDL. Okay, and we know the moment at every part is 0. So now consider the moment at the central part is equal to 0. So let's take the moment about the central part and let's consider only the left hand side of the cable and equating it to 0. Okay. Now, so take the moment about the central part which include VA into L by 2 minus H into H minus WL by 2 into L by 4 is equal to, and from that WL by 2 into L by 2 minus H into H minus WL square by 8 is equal to 0. From that you got H is equal to WL square by 8H. 8H. So from in this equation, W is the intensity of load and L is the length of the span and small h is the central dip of the cable. Okay, so by using this equation we can find out the thrust in the cable when the cable is subjected to a uniformly distributed load. Okay, and here you can see the H, that is thrust, is equal to T max cos theta, or the horizontal angle cos theta is equal to H divided by T max, and from that H is equal to T max cos theta. Okay, now the maximum tension in the cable which is always occurs at the support. If VA is greater than VB, then the maximum tension is equal to square root of VA square plus H square, and if VB is greater than VA, then the maximum tension T max is equal to square root of VB square plus H square. That means the maximum shear will be in the supports for a uniformly distributed load throughout the span. Then if the span is under symmetry, then both the supports are having the equal shear, that is equal to WL by 2. Okay, then the maximum shear is equal to square root of WL by 2 square plus H means the thrust value, that is WL into L by 8H the whole square, and which is equal to WL by 2 into square root of 1 plus L square divided by 16 H square. Okay, so the minimum tension in the cable which is always occurs in the center part, that means at that point the shear is 0. Okay, so that the minimum shear is equal to square root of V minimum square plus H square. The V minimum square value is 0. So square root of H square, that's equal to H. Thrust, that's equal to WL square by 8, which is the minimum tension at the center. Okay, now show that the shape of a cable loaded with UDL over its center span is parabolic. That means we have to show this curve or this cable is a parabolic. Okay, so at any point on the cable we know V is equal to T sin theta. So here you can see the horizontal component is H is equal to T cos theta and the vertical component is T sin theta. So V is equal to T sin theta is a vertical component of tension in the cable and V is equal to T cos theta is a horizontal component of tension in the cable, and where theta is the angle made by the tangent of the cable with horizontal. And to find the shape of the cable, let us consider the free body diagram of this section of the cable. So this is a distance h from this point, and here you can see the support A which is acted upon by reaction VA and horizontal thrust H. Okay, now to find the shape of the cable, consider the free body diagram, and we need to analyze this section. For that, apply the conditions of equilibrium, that is sigma fx equal to 0, which implies T cos theta minus H is equal to 0, and that is equal to T cos theta equal to H, and put it as equation number 1. Then find out sigma Fi equal to 0, and which implies T sin theta is equal to VA minus WH, and apply the value of VA, that is WL by 2 minus WH, and put it as equation number 2. Then equation 2 divided by equation 1 is equal to WL by 2 minus WH divided by H is equal to tan theta, and which is nothing but dy by dx is equal to 1 by h into WL by 2 minus WH. Okay. Now we are integrating with respect to h to get the equation in terms of y. Okay, and that's equal to 1 by h into WLH minus 2 LX by 2 minus WH square by 2, and that's equal to WH into L minus h by 2h. Okay, then substitute the value of h in this equation. You will get y is equal to 4hs into L minus x divided by L square, and which is the equation of a parabola, so that we can find the shape of the loaded cable is a parabolic. Okay, now in order to find the length of the cable in any curve, we know the length of the arc PQ in this figure. So this is a arc PQ or cable PQ, and this is the length DS. So from this figure, DS is equal to square root of d square y plus d h square. Okay, now divide this whole equation by h. So you will get ds by dh is equal to square root of 1 plus dy by dh the whole square, and which is equal to 1 plus dy by dh the whole square, the whole raised to 1 by 2, and which is in the form of a plus b the all raised to n. So let's take only the two terms and neglect all other terms, and which will approximately equal to 1 plus half into dy by dh the whole square, and put it as equation number 3. And we already know the equation for y. From that, find out dy by dh and substitute the value of dy by dh in the equation number 3, and we will get dy by dh is equal to 4h by L square into L minus 2h, and substitute this dy by dh value in equation number 3. Okay, now you will get ds by dh is equal to 1 plus half into 4h by L square minus L minus 2h the whole square, and that's equal to 1 plus half into 4h by L square minus L into L minus 2h the whole square dh. Okay, now that's the length of a small part. Now the length of the cable is equal to, we need to integrate from 0 to L ds, and upon integrating we will get the length of the cable is equal to L plus 8h square divided by L raised to 4 into L cube divided by 3. Okay, where H is the central dip and L is the total span and L is the length of the cable. Okay, by simplifying the equation we will get capital L, that is the length of the cable, is equal to small l plus 8h square divided by 3l. Okay, where capital L is the length of the cable and small l is the span length and h is the central dip and again small l is the span length. Okay, so this is the equation that we are using to find out the length of the cable when the cable is loaded with the UDL and the supports are in the same level. Okay, now this is a question on which the cable is carrying a UDL and the supports are in the same level. Okay, let's read the question. A suspension cable having supports at the same level has a span of 30 meter. So that small l is equal to 30 meter. And the maximum dip is 3 meter. That means the central depth, central deflection, h is equal to 3 meter. The cable is loaded with a UDL of 15 kilonewton per meter. So W is equal to 15 kilonewton per meter. Run over the whole span and 2 point loads 20 kilonewton each at middle third points. Okay. Find the maximum tension in the cable. Also calculate the length of the cable required. Okay, how will you find the maximum tension? Maximum tension Tmax is equal to square root of Va square plus H square or square root of Vb square plus H square. So in this cable, the cable is a symmetric cable, so that Va will be equal to Vb. Okay. Now, since the loading is symmetrical, Va equal to Vb equal to 15 into 30. That means 15 into 10 plus 10 plus 10 plus 20 plus 20. Okay, that divided by 2. That whole divided by 2 will be the individual reactions, and that's equal to 245 kilonewton. And to find out the value of thrust, we can consider moment at the central part is equal to 0. So Va into 15, that means this reaction Va into 15 minus 20 into 5. Okay, and that minus 15 into 15 into 15 divided by 2. Here the intensity of load is 15 and the length of up to the center is 15. So 15 into 15 into 15 divided by 2. That means the moment. Okay, is equal to 0, and which implies the thrust is equal to 629.16 kilonewton. Now, the maximum tension in the cable is equal to square root of Va square plus H square, and that's equal to square root of 245 square plus H square, and that's equal to 675.17 kilonewton. So now you got the value of maximum tension. So now you have to find out the length of the cable by using the equation L plus 8H square by 3L, and where small l is the length of span and that's equal to 30 meter, and now H is a central dip and which is given in the question as 3 meter, so the total is 30.8 is the length of the cable. Okay, YC, here you can see the minus H into YC plus VA into 7 minus 1 into 7 into 7 by 2 is equal to 0. From that you got H is equal to 7.56 kilonewton, or you can use the equation H is equal to WL square by 8H. Okay, so now the reaction Tmax is equal to square root of Va square plus H square, and that's equal to 10.3 kilonewton. So the inclination of this Tmax with the horizontal is given by tan theta is equal to Va divided by thrust, and that's equal to 7 divided by 7.56, which implies theta equal to 42.80 degree. Okay, here you can see the free body diagram of the cable. And so let's find out the horizontal distance L1 and L2 first. Okay, so consider the cable is subjected to a UDL of intensity W per meter length over the entire span L. So let the horizontal distance between A and C be L1 and C and B be L2, such that L is equal to L1 plus L2. Now the horizontal thrust at support be H. Okay, we already know. So as we all know, the cable can take only axial force, that is bending moment at every point is 0. So let's take Consider a point D on the cable and consider the free body diagram of the portion CD of length X with C as origin. So consider this section of length CD and which the distance between C and D is X, and which is acted upon by a UDL of intensity W per meter length. Okay, now consider the equilibrium of portion CD. From that, sigma Fx equal to 0 implies T cos theta minus H, that is T cos theta is a horizontal component of tension. So T cos theta minus H is equal to 0, and that implies T cos theta is equal to H, and put it as equation number 1. Now sigma Fi equal to 0, and that implies T sin theta minus Wx, where W is the intensity of UDL and that into X, and that's equal to 0, which implies T sin theta equal to Wx, and root of H2 is equal to L1 divided by L2, and which can also be written as square root of H1 divided by square root of H2 plus square root of H1 is equal to L1 divided by L1 plus L2 by simply adding a 1 in both sides. Okay, now, and that's equal to L1 divided by L. So therefore L1 is equal to L into square root of H1 divided by square root of H1 plus square root of H2, and similarly L2 is equal to L into square root of H2 divided by square root of H1 plus square root of H2. Okay, now to find the horizontal thrust H, consider the entire cable and consider the left hand side to section C. Okay, so which implies MC is equal to 0, and we have VA into L1 minus H into H1 minus W L1 square divided by 2 is equal to 0, and that implies VA equal to WL1 by 2 plus H into H1 by L1, and put it as equation number 4. Also consider the right hand side of the section is equal. Let's consider the right hand side of the central part and equate to 0. Okay, equate the moment to 0, so that H into H2 minus VB into L2 minus W into L2 square divided by 2 is equal to 0, and which implies VB equal to WL2 by 2 plus H into H2 divided by L2, and put it as equation number 5. And let's add 4 and 5, that is VA plus VB is equal to this equation, and we already know the value of VA, that is WL by 2, and VB, that is WL by 2, and W into L1 plus L2 by 2, it is WL by 2. So 1 WL by 2 will get cancelled, and we get H is equal to WL by 2 divided by H1 by L1 plus H2 by L2. Now substitute the values of L1 by L1 and L2 which we got earlier, and rewrite this equation as like this, and multiply and divide this equation with L and simplify, so that you will get H is equal to WL square divided by 2 into square root of H1 plus square root of H2 the whole square. So this is the equation for thrust H. Okay, now from the equations 4 and 5 we can find VA and VB, and next is to find the length of the cable, and by referring this figure L1 we already know and L2 we already know, and ACB dash which is nothing but 2L1. Okay, and the dip is H1, then coming to A dash CB, and which is nothing but 2L2, and the dip is H2. Okay, so the length of the cable ACB, that means the original length of the cable is the average of ACB dash and A dash CB. Now we know ACB dash are in the same level, that is A and B dash are in the same level. So let's use the equation L is equal to L plus 8H square divided by 3L to find the length of this cable ACB dash, such that ACB dash is equal to half into 2L1 plus 8 H1 square divided by 3 into 2L1 plus 2L2 plus 8 into H2 square divided by 3 into 2L2, and simplifying this equation you will get the length of the cable ACB is equal to L1 plus L2 plus 2 by 3 H1 square divided by L1 plus 2 by 3 H2 square divided by L2. So this is the equation to find out the length of the cable. Okay. And we already know VA plus VB is equal to 100, and from that VB is equal to 100 minus 56, and that's equal to 43.99. So VA is greater than VB, so that the maximum tension on this cable is equal to square root of VA square plus H square, and that's equal to 203.89 kilonewton. So that's a maximum tension in the cable. Okay, hope you all understood this section, and thank you for watching. Thank you.